Welcome back to Math 30-2. We're on lesson 7 of Unit D, combining the laws of logs. So last lesson we looked at, we formed these logs, we did a little investigation. We saw that if the log of, so if the argument was a product, it would be the same as if we added them, okay? Same thing with the quotient and subtraction. And then when we had an exponent, okay, that power could come down here as the coefficient. So now we're going to be looking at basically a combination of them all so that we can write things as a single log. Okay, example 1. Students were asked to express 4 log base x 2 minus log x 8. Once again, these bases have to be the same in order for us to use these laws, just like for exponential laws. Okay, so we got Shane, we got Emma, we got Clayton. We see that they get to 3 different answers here. So only one has determined the correct answer. Determine which student is correct and explain the errors made by the other 2. Okay, so here we start off here. And I see that they have changed this 8 to 2 to the power of 3 and then brought it to the front. Okay, and then they took 4 log minus 3 log equals 1 log. Okay, that looks good. I think Shane's doing okay. But let's look at Emma. So Emma, what did Emma do? Emma used the power law to put it back up there. That was awesome. That was my spit right there. That came from my mouth. I'm gonna leave that in. Okay, so then she did the actual, she evaluated 2 to the 4 is 16. And then what the heck did she do? Oh, she treated it like it was 16 minus 8, I think. But that's an error, right? From this point right here, she should have used the quotient law, which would be 16 over 8, which then this would be equal to 2. So that's where she made her error. Let's look at Clayton. What the heck did he do? Oh, silly Clayton. He did 4 times 8. That's not right. So he made the error right in the beginning there to get the wrong answer. So yeah, he multiplied 2 times 8 as opposed to writing 2 to the power of 4. Okay? So 4 times 2, that's not what it should be. It should be 2 to the power of 4. Okay, cool. So I think that would be enough. You could just write down like the words there, but showing that is good. Okay, so then number 2, using the laws. So now we're tasked with doing this. So we're writing it as a single logarithm. So I'm looking at this. I see that there's a coefficient in front of both of them. Both of my arguments can be written as base 2, so that might be helpful. And I see that it's subtraction, so that's quotient law, right? So let's see, let's put these powers on it, okay? Because I know if I take 1/3, so 8 to the power of 1, oh my God, to the third is just 2, and 16 to the power of 1/2 is equal to 4. So let's see where that takes us. So log A, 16 to the power of 1 over 2, so that's the same as a square root, minus, log A, 8 to the cube root. So if we actually do we evaluate that, the square root of 16 is 4, and then the cube root of 8 is 2. Okay, then I can just use my quotient law, 4 over 2, which is equal to log A of 2. Okay, so I've written it as a single logarithm. Let's look at this next one. So all the same base, so this is the common logarithm, and I've got subtraction. So this would be one where I would go, okay, subtraction, I'm gonna put those on the bottom. But I guess first I would need to write this. I would need to show that I'm writing my power law, and then I would just write that, because subtraction, they both go on the bottom with the quotient law. And then my last step, I would just evaluate, okay, well, a divided by a squared, that's gonna cancel out. I'll be left with 1, and then I'll be left with 1a. So then my final answer would be 1 over e to the 5a. Okay. Page 244. So same thing, single logarithm. I got some funky numbers here. That's okay. So write the expression as single and then evaluate. So that means like what, like actually put it into your, either your like mind calculator or your actual graphing calculator. So single log, I need to put that up there. So this is going to be equal to log base 6 4 squared plus log base 6 2.25. Okay, then I'm going to use my product law. Okay, so I use my power law, power law. And then I'm going to have log 6. And then so 4 squared is 16 divided by 2.25. Okay. And then from there, so that's as a single log. And then 16 divided by 2 1/4, I think is a full number. Oh, no, it's not. 17.11. Okay, that's like weird. One repeating. I think that what I would rather do from here, so like you could do that and then you could plug it in, but I think I would use the change of base formula and I would go back to here. So log of 16 over 2.25, just because that's going to be a more exact answer, and then over log 6. Okay, and then I'd put that in, which like we can, like it's going to be the same as if I just, like if you've got the Inspire, you have access to this right here, right? So that's going to be 6, and then what was it, 16 divided by 2.25. Okay, and the answer is 1.09. Does it say, doesn't say what to do it to, 1.09. But yeah, there we go. That was a weird one. Usually they want us to leave it as a, like a whole number. Okay, if log base 5 of p, argument p is 12, then determine the exact values of all of these. Okay, well this right here is 12. Okay, so like that's this unit here. That would be, so like part of this, right? Like, but this is being multiplied, so I could split it up into log 5 plus log 5p. So that's using my product law. And then this one here, same thing, I would split it up and then probably pull this out front. So but either way, you're looking to make this expression so that at least part of this breaks down to just log 5p, because then all we have to do is substitute in that it's equal to 12, okay, and it's 60. So then here, we split it up, we used our product law. So this we know is equal to 1, and then we know that's equal to 12, so that's 13. And then this one here, so we'll bring the 3 here. Actually, I'm going to leave that there first. I'm going to leave the p there, and I'm just going to do like this multiplication. So I'm going to do log 525 plus log 5p cubed. And then I'm going to go log 5 squared so that I know it's going to be equal to 2. And then I'm going to bring the 3. Now I'm going to bring it up front. It would have still like worked. 6 of one, half dozen the other, but I think this is just like an easier way of showing it. So then I'm going to have 2 plus 3 multiplied by, so here's my 12. Okay, so it's going to be 2 plus 36, which is 38. Cool. All right, last question. This is a nice short one. So same idea, okay, but now I've got 2 variables. So if log 2x is equal to a, then use the law of logs to show that log base 2 of 32x squared is equivalent to 5 plus 2a. So this is what I'm going to be breaking down, okay? And I'm going to use my product law. I think I'm going to try that first, okay? So this is going to be equal to log base 2 of 32 plus log base 2 of x squared, okay? And then I'm going to change 32 into 2 to the power of 5. And then I'm going to bring that x, I'm going to use the power law to bring that, because then this is equal to 5. And then there's my log 2x is equal to a. So there we go. We have proved that. So therefore, log base 2, 32x squared is equal to 5 plus 2a. Cool, cool. So go ahead and do your assignment, and I'll see you for the next lesson.